Okay, time to get back into lesson 7.4. Second part. Let's look at some different types of questions that involve adding and subtracting rational expressions. See what these are all about. Okay, so in this case, we don't want to jump right into the same method we used in the last lesson. The reason being is you're going to have a hard time simplifying this expression into lowest terms because you're going to be missing some common factors. So first thing I'm going to do is I'm going to notice that the second denominator has a greatest common factor of 3. So what I'm going to do is factor out a 3 and picture the denominator looking like that. And now what I'm going to do is carefully think about what's the least common multiple or least common denominator between these two. So what I'm looking at here is that I see a number 3, and then I also see a factor of x minus 4. Now that's common to both terms, isn't it? So I'm only going to need to write it once. So here we go. So I'm going to have a 3 here, and then I'm going to have an x minus 4, and I'm going to show you why this is the greatest common factor. Or I'm sorry, the least common multiple or a common denominator. So let's go ahead and get some of these highlights out of here. Let's take a look at our numerators. I can see I've got an x and a 2. So we will keep those intact. Let's take a look at our denominators. So my first denominator is x minus 4. Let me compare that to this denominator. What do you notice that's different? The 3, right? So that can be written as 3x if you like. Second denominator, what's different? Absolutely nothing, is there? No. So you could put times 1, but no sane human being would do that. So I think we are ready and prepared to write this final answer. So what we have is a denominator of 3 times x minus 4. In numerator, this is 3x here, minus 2. Do not be tempted to cancel those 3's. There's your final answer. So instead of just going through and multiplying denominators together, we'll look for the least common multiple instead. Let's go ahead and try this one. Can we do a little bit of factoring on this? I think we can. All right, everybody see that? Okay, now let's look here. Can you tell what the common denominators are going to be? I think so. Let's go for the least common multiple. So I'm seeing a 6, and I see an x plus 4 is in common to both. That's the least common amount of items that are in there. Okay, then we got a 13 and a 2. Now it's time to go ahead and compare some denominators, and let's see what we have. So here's the old denominator, here's the new. I'm not seeing anything different. So technically you would multiply by 1, but once again, no sane human being would worry about that. New denominator, old, what's different? A 6 is, right? Multiply by 6. I think we are prepared for our final answer. This is 12 in it, so 13 plus 12, 25. Now, if 25 and 6 had a common factor, we could reduce them, but they do not. Let's go on to the next problem. Starting to get the idea. All right, We can do some factoring, right? So I see a common multiple there. Alrighty. So now I'm going to look at these. I'm going to think we're going to have a 2 and an x minus 2. I'm going to rewrite my numerators, but I know they're going to end up changing. So I've got a 13 and an x. Now let's compare the denominators to see how they have changed. There's the old first denominator. Here's the new. They're the same. I'm not going to change the numerator then. Those are the same. There's the old second denominator. Here's the new one. They're different by a factor of 2. So I'm going to multiply that by 2, or that's 2x up there. All right, I think I'm ready to go here. Here's my common denominator. 13 minus 2x. Do not be tempted to cancel those 2's. Cannot be done. All right, let's go on to another problem. See if you can work on this one here. I think I'll factor out a 5 and a 4. Let's see if you can start figuring this one out. I'm thinking we've got a 5 and a 4. Okay, so can you think of a common factor, or I'm sorry, a common multiple between 5 and 4? How about 20? I'm thinking 20 is going to work well for that. So I'm going to use a 20. And then the x minus 2 is in common to both. No need to use x minus 2 times x minus 2. That's a little too much. Of course, my numerators, I've got a 2x. And I got x minus 5 over here. All right, let's see how the denominators have changed, and we'll change our numerators as well. Old denominator. New denominator. What's different? Well, what's 20 divided by 5? It's 4, right? So this needs to be multiplied by 4. Old denominator. New. What's the difference between those? 20 divided by 4? 5. Okay, so what I'm going to do is, how about I do a little bit of work up here? That's 8x, isn't it? Think about distributive property. That'd be 5x minus 25. And this is going to move through there. So it's going to be minus 5x plus 25. So here I go. Denominator. Numerator is 8x minus 5x, 3x plus 25. Done. Okay, last question. Let's do some factoring. Okay, so you got numbers 2 and 5, right? What's the least common multiple between those two? 10 is. They both divide into 10. X minus 3 is in common to both. I'm going to rewrite my numerators. Now, I got to look and see how my denominators have changed, and then change my numerators. What's the difference between those? 10 divided by 2? 5. What's the difference between those two? 2. How about we do a little bit of work on these? Let's do a distributive property. So this would be 5x plus 10, 2x plus 6. Of course, this is going to be affected by that negative, so it'll be negative 2x minus 6. All right, let's get the final answer. All right, 5x minus 2x, that'd be 3x. 10 minus 6 would be 4. I think we're all done. Here we go.